Hello.
Okay, let us start. Our last subtopic, 23.8 optical waveguide. After that, we go to 24 next week. All right, remember to do your question tonight. We discuss some tomorrow. Explain the basic principle of fiber optic and waveguide. Say the application of fiber optic and waveguide. Yeah, you can see this one. This is a fiber optic, or some people call it optical fiber. Right? Optic fiber or fiber optic. Okay, it's just to remind you, you need to know roughly the value for your either wavelength or your frequency. Right? That's your fiber optic. Usually we are more interested in this area lah. Either white light or infrared light. Right? And see can be quite innovative or quite strange to us, or sometimes we quite beautiful. Right? These are what you use optical fiber or fiber optic. Okay, let's just review our physics on total internal reflection. Right? Medium one has reflective index. That's a medium one. Water, reflective index N1. Medium 2, air, reflective index N2. Theta 1 is the angle of incident. And angle of incident, that's the incident ray. Right? Make sure you have your worksheet ready to copy down. At small angle of incident theta, if this is small, theta 1, the incident ray is partly reflected, which is here, and partly refracted. Okay, so this angle of refraction is your angle of reflection. And remembering that you are coming from N1 is greater than N2. So that angle in air is going to be larger. Right? Angle of refraction is going to be greater than the angle of incident. So as we increase our angle theta, theta 2 will increase. At a certain angle called C, critical angle, this refracted ray will be at 90 degrees to the normal. Right? That's a normal. At critical angle C, the angle of refraction is 90 degrees. So if we increase our angle of incident theta 1 to greater than C, then we see that this one will now move in together with the reflected ray. So now we don't have refracted ray anymore. Right? The reflected ray combined to form the refracted ray. Only one refracted ray. So we call this total internal refraction. Okay? No, at total internal refraction, there's no refraction. At critical angle C, okay, that we have reviewed earlier already. Right? N1 times sine of C is N2 times sine of 90 degrees. This is 90 degrees. Right? 90 degrees is 1. Then we take our N1 out. So that is our equation. N2 over N1. Okay, what are the conditions for total internal reflection number 48 in your worksheet? Yeah, what are the conditions?
Critical angle is 90 degrees.
What angle?
Critical angle is 90 degrees.
That's all.
Angle of refraction is more than angle of incidence.
Angle of refraction is greater than angle of incidence. No, that's not the condition.
Oh, uh, both angles are the same.
No, this is your SPM work. And now pay attention in class. The beam of light must travel from medium of high reflective index. This one, it cannot come from air. It must come from water or glass first. High reflective index to low reflective index. That means your N1 must be greater than N2 before you can have total internal reflection. That's the first condition. Angle of incidence, this angle must be greater than the critical angle. Right? At critical angle, this will be 90 degrees. The angle of reflection. Okay with that? Write down, write down. This is for memory work. Understand and memorize it. Right? These are the two conditions. If you want, you can write down also this condition that we have derived. Right? In case you want to define what is C, C can be obtained from medium N2 over N1. Okay, need more time? Right, important. The incident ray must be in the denser medium to less dense medium. And the incident angle must be greater than the critical angle. And the critical angle is given by reflective index N2 divided by N1. Okay. Let's look at optic fiber. Right? Thickness, very fine. And pure fiber of glass, made of glass, pure glass. About 120 micron in diameter. Average human air is about 50 to 70 micron. So it's actually slightly thicker than the diameter of the human air. Okay, that's the structure. Core, this is a core. Remember, more core and cladding are made of glass. This is a core. Thin glass fiber of diameter 0.1 millimeter or less. Reflective index is N1. Right, so the light travel in this core. We send light ray into this core, or information in the form of light. So we send to this core. Cladding made of glass of reflective index N2, and N2 is less than N1. Repeated total internal reflection occur as at the core cladding boundary. So the light ray as you send in at an angle will be totally internally reflected multiple times before it comes out of the end there. Right? Coating can be plastic. What's the purpose of coating? Plastic coating that protects the fiber from damage. Right? You don't want the glass to be scratched or break, so you have to protect it with a plastic. Okay, let's go to the physics involved. There's your signal or pulse or information at an angle theta. Light travels to the core of fiber optic by bouncing off either optical fiber or fiber optic by bouncing off the cladding. That's your cladding. Two-dimension cladding. That's your core. That's your cladding. By total internal reflection, So as it reflects, total internal reflection at a cladding core boundary, and then at cladding core boundary, another total internal reflection here, and carry on. A single mode fiber carries one signal. Right? That's called single mode. A multiple mode fiber is able to carry more than one signal. Right? Each signal is just a pulse of light, that's all. And the pulse itself will carry the information. Right? Fiber optic or optic fiber carry information in the form of pulses of light or infrared radiation. So it is digital, if you like. Right? On, off, that's all. For total internal reflection to occur at the core cladding interface, part there, total internal reflection to occur, the light entering the fiber optic at an angle less than theta max. That's a theta max that it must enter less than that. Right? Theta max will affect your alpha. Alpha will affect theta 1. Right? Critical angle C, this will be 90 degrees. It's given by N2 over N1. We have derived this equation. That's your critical angle. So that is your C. This is your alpha. This is your right angle triangle. So alpha C plus alpha is 90 degrees. So for total internal reflection, that theta 1 must be greater than the critical angle given by this equation. Okay, so critical angle is 90 minus alpha. So that's another way of saying that the theta 1 equals to 90 minus alpha. So 90 minus alpha must be greater than C. Okay, that's your theta 1. 90 minus alpha is greater than C. Or take this across there. Take this one across. The alpha must be less than 90 degrees minus C. Okay, so that theta 1 must be greater than your critical angle. That alpha there must be less than 90 minus C. I'm not going to go through all the physics involved is in your book because it's not mentioned in your syllabus. Okay, I don't think we worry about all this formula. I think, okay, I think we will not bother about this part. Just keep in mind that there is a maximum angle that it can go in. Angle of incident here, if it's greater than maximum angle, you total internal reflection will occur here. That's all you need to know. Okay, I don't think I want to go into the math involved. It's too complicated. Not mentioned in your syllabus. Okay, transmission. Right, that's a condition for to get your sine theta max. That's a theta max. As I say, I'm not going to go over that. Right, that means this is your 2 theta max. This 2 angle together. Within that angle, it can be totally internally reflected. Okay, let's go to optic fiber. Uses. Unify user. Right? Telephone system. The cable TV system. Internet. Medical imaging and medical engineering. Advantages is thin. They are much lighter than copper wire. Right? If it's copper wire, it's current I square times R. But optic fiber is made of glass. So no I square R. Require less power as no resistance. Right? No resistance, so less power dissipated. Information can carry far more the channels of information. That means it can carry more information rather than go into channels of information. It can carry more information. Interference are immune to electromagnetic interference and are harder to hack into without detection. What is happening is, if you use copper wire behave like an area. So when you pass alternating current through it, current is your signal lah. Then the changing signal will cause a wave to pass out of the copper wire. So that's how people listen to your conversation. That's called interference. But glass doesn't have this problem. Attenuation, that means amplitude becomes smaller. Conduct signal or voice or computer data in the form of light pulses for 50 kilometers. That means it can send the signal or information a long distance. Before we have to use a repeater to boost the signal. Okay, compared to copper wire, you need an amplifier, right, to boost the signal. But this can travel long distance before we need to boost it. Okay, so this one summarizes for you the same thing, right? Can carry large amount of information. Signal power loss in optic fiber are relatively small. Right? It's not I square R. It's made of glass. So it means that less amplifier required lah. You don't need to amplify it too often. You got regenerative amplifier. Cost of optic fiber much less than that of metal wire. Right? It's cheaper than copper wire. Thinner implies easier handling and storage. If it's thin, it's easy to carry around. Not like copper wire, so heavy. And then store, you don't need to be so expensive because it's thinner. Right? Storage should be easy. No, don't need to have a expensive warehouse. Then immune to electromagnetic interference, no crosstalk. That means no one can listen to what you're talking. Remember, your speech is like alternating current. So when it's sent in copper wire, it's alternating current. So it will radiate out as maybe softer, but people can listen to what you're talking about. That's why in the old telephone system, during my parents' day, right, sometimes you can hear people talking. That's called crosstalk lah. So use optic fiber or fiber optic, high security. They are more secure. People cannot listen to your conversation. And then you can lay alongside existing routes such as electric. I can lay on railway line. Railway line will make noise, but it cannot. The fiber itself made of glass, so it doesn't enter the fiber. If it's copper wire, it will enter the copper wire, but this one, it won't enter. That's what it means by immune to electromagnetic interference. Clearer phone conversation or TV reception. That's why you can enjoy your TV clearer. Disadvantage, don't need to bother lah. Right? How information is transmitted. And this is all your info need. Don't need to go too far. Carry information in the form of pulses. Right? That's your signal, your information. Pulses of light or infrared radiation. The pulses are provided by laser, and the light produced has very high frequency of the order of 10 to the power 8 megahertz. Okay, let's go to waveguide. What are waveguide? It's a structure that guides waves such as electromagnetic waves or sound waves with minimum loss of energy by restricting the transmission of energy in one direction. Just like here, right? Without the waveguide, we are sending the signal through air, and it will go in all different directions. But with the optical waveguide, in this case, optical fiber, then you channel in one direction or one dimension. Right? This is for microwave waveguide. Without physical constraint of waveguide, wave intensity decreases according to inverse square law. That means that as you go further and further away, the intensity becomes smaller and smaller, right? Or we call it inverse square law. R is the distance from the source as they spread out in 3 dimensions. But optical waveguide, we channel in one direction. There are different type of waveguide for different type of waves. We are not interested in that. We are interested in this one only. The original and most common meaning is a hollow conductive metal pipe used to carry high frequency radio waves, particularly microwave, like this one. Dielectric waveguide are used at high radio frequency and transparent. We use glasses for optical waveguide. Transparent, dielectric, waveguide, and optical fiber serve as your waveguide for light. This is for your information. You don't need to go that far. In acoustic, that is your sound wave going into the cone there. Air duct, there's your air duct inside there. Are used as waveguide for sound in musical instrument and loudspeaker. Right? That's why you have the shape of your loudspeaker that way. Right? Cone there. And especially shaped metal rod conduct ultrasound wave in ultrasonic machine. Right? This is extra information for you. You don't need to know all this. Or modern spectroscope, listening to internal sound of animal or human body. That's where you put on the body. That's where you put on the ear to listen. Okay, so we are more interested in optical waveguide. It's a structure that guide wave, restricting the 3-dimensional propagation of wave to a single dimension. Advantage, low attenuation or loss of intensity. So optical waveguide is a structure that guides the light wave by constraining it to travel along certain desired path in a transparent dielectric due to total internal reflection. That one summarized for you in the picture there. It's 1 dimension and it transmits the light signal or light information by total internal reflection. If the transverse dimension of the guide are much larger than the wavelength of the guide light, then we can explain how the optical waveguide works using geometry optics. That's why we have done that. We have shown you just now previously how total internal reflection occurs for the light. Total internal reflection occurs when light is incident on the dielectric surface at an angle greater than critical angle. Right? Refer to your note earlier. I'm just summarizing for you. So a waveguide traps light by surrounding a guiding region. There's a guiding region called the core. That's the core, optic fiber or fiber optic, made from material with reflective index and core, with material called cladding, made from material with reflective index. Right? The reflective index cladding is less than the reflective index of core. That's the important thing. We want total internal reflection to occur. So light entering is trapped, right? Trapped as long as your sine theta, right? That's sine theta, is greater than your cladding, reflective index of cladding over reflective index of core. I think that's all you need to know. You need to go to all the math and go too far. Light can be guided by planar. It can be planar rectangular waveguide, or it can be optical fiber. Right? It can be cylindrical, can be rectangle, but we are more familiar with the cylindrical type. Right? Core, just summarize for you what we have studied. Core is the inner light carrying member with high index of reflection. Cladding is the middle layer which serves to confine the light to the core. Right? So it cannot go out, cannot be reflected at the cladding. Total internal reflection occur. It has a lower reflective index. Buffer outer layer will serve as a shock absorber to protect the core and the cladding from damage. The coating usually comprises one or more coats of plastic material. We can either one layer or two layer to protect the fiber from physical environment. Right? You don't want to damage the core or the cladding. They are made of glass. Sometimes metallic sheets are added to the coating for further physical protection. So if you think that it may be damaged, then you use metallic coating rather than plastic. Okay, any comment? We have completed already. Anything to ask? Yep, all these formulas that you need to remember. All these formulas you need to remember. What is an optical waveguide? Ken? Yep, what's optical waveguide? A waveguide is a structure that guides the wave. In this case, it's a light wave, such as electromagnetic wave, with minimal loss of energy by restricting transmission of energy to one direction. Okay. Optical waveguide is the core. Right? The cladding is to restrict the light from going out. State 3 advantages of fiber optic. Okay, can state for me 3 advantages of fiber optic. Use a book if you have to. Go and find the answer for me. Can? Should have written down just now when I teach you. Then you to solve all your problem. You need to make an effort, Srini. Nobody can help you. Can carry more information. Immune to electromagnetic interference. And cheaper also, because it's made of glass. Right? The other one is labeling. Label that. Core, cladding, and coating. State the function of the core is the inner light carrying member with high reflective index made of glass. Cladding, the middle layer will serve to confine the light to the core. There's a lower reflective index compared to the core. Okay, you don't know, copy it down. And just go and revise. And then answer the question in your book. So tomorrow we will start at 3 o'clock. We will do question on focus. So I pay you to spend some time on it tonight. Okay, do you need more time to copy?
No, Chacha, I want to ask something. Means all the videos are posted on YouTube, right? SEM2
Yeah,
and
yeah,
SEM3.
it's YouTube. I send you every week also after the lecture. That's the reason I am so efficient. Because I do it after class and then send it out to you. If you ask me to do another time, I forget everything. That's why it's important for you. After I teach you, you must go and do your homework to force it in. Review through and do your homework. No shortcut. Okay, any question to ask? If not, I see you tomorrow.
No,
Okay, if not, I see you tomorrow. I'll stop here.
So just see those videos only, right? Check if I don't understand anything.
Just review the video tonight and then do the homework. And then whatever you cannot understand, you ask tomorrow. That's the reason for sending you.
Also.
That's the reason for sending you today, so that you can review, do the exercise, and then ask question tomorrow. Right? After that, next week we'll go to a new topic.